Well, good afternoon, everybody. I'm glad you could make it, and we're going to go through the SaveAir, the starting system to convert a in-head mechanical air starting system into electronic um, programmable one. So I figure out how to get my screens to change. Okay. We developed a system with the help of Xline a number of years ago. They had a mechanical way of doing this where they could change the injection timing on the engine with a mechanical arm and stuff. And they approached us many years ago about if there was a possible way to do that electronically. So we're working with our engineers, and we developed a system that's really slick in how it works. Very simple to program. And very easy to install on the engine. So the reason they call it the SaveAir because on certain engines it actually does save air. We start out with um, a full injection cycle like the mechanical system was, but after we have the engine starting to roll, we're able electronically be able to pinch that duration back to a minimum to maintain speed. So it does, as you'll see in a few slides here, it does actually save quite a bit of air on most cases. And we'll get into some of the ones that the reason we have to use the air a little longer because of mechanical issues with the engine. So again, with the idea of saving air, with all the air compressors, electricity, air dryers, and all that stuff it takes to maintain an air supply to start these engines. Normally, it's got to be up to like 250 pounds. And, and to get there with an air compressor, starting at atmospheric pressure, it takes quite a bit of time and energy to get there. So, and this helps save that air into your air system. Um, it's got a so unique device on it that positions the knows where the injection points are electronically, compared to like having a ring gear or pickups on the flywheel where you have to roll the engine so many times to figure out where it's at before you could fire like an ignition or something. This has a special program chip that after it's calibrated, it knows exactly where the flywheel is at, so it knows where to inject the air at. So it's a pretty slick system. In one case here, on this particular engine, we're getting into a little more. We did record the pressures and flows and stuff on the engine compared to the mechanical system, and then after the SaveAir was installed, and we were saving up to like 70% of the air on that engine. So that you equate that to multiple engines, you could do multiple starts with different engines. It also has a unique deal on the dead spots. On some of the mechanical systems, as you'll see in a couple of slides here, the way the system is set up, there are certain times that you get in the middle of an injection cycle where it can't get any air to the cylinders, where this here you can program it so you can get the cylinders to overlap in most cases, and that eliminates that dead spot and the headaches of going out there and trying to bar the engine to get onto a cycle that you can actually push more air into the cylinders on it. So more reliable remote starts. Again, back to the idea that you don't have to have guys on locations in most cases. You could start this remotely because it eliminates a lot of these dead spots that some of these engines have. So again, it does save a lot of air. So you can do multiple starts or start other engines in the station. So this is the components here. The first one you see is a logic module here. That has been changed to a newer version, a newer housing. The inner disk, computer disk is still the same, but the outside guts have changed on it. We found a more efficient way of making that. So the display can be mounted anywhere, or it does not actually be needed. You can actually run all this information to a PLC or some type of HMI to display that. Otherwise, it's all programmable through the display, or you can do it from a firm or a terminal program that we have. So, and then we offer 2 output boxes depending on how many cylinders you have and how many outputs you need. We can go up to 20 cylinders. So this is what the display would look like. It was one of our standard displays, and this is where you can get into what degree the flywheel is at, and it also, if you wanted to do a test run on the system for troubleshooting purposes, it allows you to get in there where you can actually fire the solenoids on different cylinders or all of them if you need to do some troubleshooting. So again, this crankshaft positioned on it, and one thing I put a little note in there from the mechanics out there that when you're borrowing the engine over to set your valve lash and stuff, this is sort of a really cool tool because it knows where the flywheel's at. So when you're borrowing the engine over, you can look at the screen on that, and if you want to get the top dead cylinder on cylinder number 4, you can just find out where top dead center comes up at, and then you can just roll this engine over until you get to that part of the flywheel, and then you know you're on top dead center with it. So because it's very, very accurate. So it's sort of a neat tool besides the idea of being a starter system that it can also be used on the engines for doing mechanical work. So I said again, it knows exactly where the starting area is, so it knows where to inject the air and what solenoid to get the engine started. And it works on 2 cycles or 4 cycles. You program it either way. You can tie it into a PLC or a SCADA system or our DE4000. So it's got some nice features with that. So, and it's also Div 2 Group C and D hazardous areas it can be run in. So. And at startup, like I said earlier, it knows where to inject the cylinders with air. And the other neat features of that, because some of the cam-driven injection points, you have to rely on the cam lobes. So you do have some overlapping cam lobes to inject air in multiple cylinders at the same time. Where with this here, being it's electronic, it doesn't rely on a cam lobe to open the valve and then close the valve. It snaps the valve open. So all the valves, when they're charged, are all fully open. So you can get a massive amount of air coming into the cylinders to roll it over. And then after you get it up and running, you can program the box to maintain a certain speed on the engine, because the older mechanical systems with the engine is cold and the oil's thick, that rolls over slow. Or you got to be able to set your panel up for the idea of being to start it when the engine's cold and running slow, and then when the oil's hot, it runs faster. Well, we can program this to, when it gets up to a certain speed, to maintain that speed by opening and closing the solenoids on it and give just enough air pressure to the cylinder so it has a steady RPM. So it's for better starting. And also, with the idea of saving air on it. So, and then once it lights off, we can automatically, after it senses a certain RPM, it automatically shuts itself down. So, in the old mechanical drive system, you can see all the mechanical parts in there, the springs and all this stuff to wear on that shaft and stuff. All that goes away. And it's all done electronically, so really cuts down on the mechanical maintenance on it. This is another picture of that. In there you can see all the components that go with that, so and manage to maintain that all the time. So, and all them parts are still moving after the engine starts also. So so they just sit there and wear out while the engine's running. This is our logic module. This is what the inside on. There's no moving parts in there except for a bearing where the shaft comes in. If you notice the little bolt over here in the corner, or in the center of it, there's a little magnet in there, and then there's a little computer chip in here that runs on, and that's how we know where the TDCs of all the cylinders are when we program it. So it's again, it's very, very accurate, and you don't have to roll the engine to begin to find that out. It knows what that is from the setup program you put into it. So this is comparing the old version compared to the new version. This was the one here on the left was the ones we had originally, and then we determined that we could put that same board into our alternator housing, that we can produce much for a lot less money on it, so it keeps the cost down on it. And this is a side view of that. So, and that also ties in really easy to the old mag drives and stuff on the engine. So, and this is one mounted on the engine here. Now, if you notice the bracket behind this, this is something that's made by a third party. X-Line makes that, and I also believe Aegis makes that. If you're looking for a supplier for that, Ultronic, as far as I know, we do not supply that. You have to go to a third party for that. So, you notice down here where it says the RS-485 wire, this is tied into a laptop somewhere along the line for programming it. So if you are programming it, you can't look at the display and the computer laptop at the same time. You can either do one or the other. So you can see where they've unplugged it from the back of the display and hooked the two wires for the RS-485 up to the laptop. So, and this is the layout of it. It's fairly simple. In most cases, you can still utilize the old air piping on it because we're just going to tap into that with an air solenoid, and then we're going to turn the mechanical valve in the head, the OEM valve. We're going to open and close that by pushing air through the solenoid on it. So, and it also has got some neat features in it. You can set it up where it will purge the engine after so many revolutions, and then we allow that. In that case, we might turn the ignition on later, so we can get a good purge, so you're not going to get a backfire and stuff on it. And then we can also just, if you pressurize the air system, that will trigger a pressure transmitter, and then that also can give a signal to the device to tell it to turn on. So, again, this is another layout of it. This is the adapter I was talking about. Every engine has their own little setup on it, and there's been multiple ways to install that. Sometimes it goes on the camshaft. I've seen this where they've actually mounted it on the back of an oil pump because the oil pump was tied directly to the crankshaft on it. So, some of the cam drives, you can pull the housings off the back of them. Or the ideal way would, if you can get to an old mag drive that's running the same speed as the crankshaft, it's an ideal place to put it. So, again, this part has to be mounted somewhere on the engine, so it knows what speed the engine's turning on it. So, yeah, and this is our main problem with this system is the mechanical valves in the heads. These valves have been with the engine. Most of them are original ones, so these engines were put in back in the 40s and 50s and 60s, and these valves have very little maintenance done on them. They just tear them apart and clean them and put them back together again. And the problem with that is, over a period of time, they wear out, and there's some of them don't even have any O-rings or any sealing rings in here. So when the 250 pounds of air comes in at the bottom of the header, it leaks by these, and it gets up underneath the piston. So in some cases, it's got 200 pounds on it, and then we're trying to put our solenoid, we're trying to put another 200 pounds on top of it. So they're equal pressure, so the valve doesn't operate very well. So they do have to have a maintenance done on them. To put this system on, we do, ask that the customer either replace the valves or have them rebuilt in a way that there's more than just cleaning them up, because we need a fairly tight clearance in there to try to eliminate that leakage by underneath the piston on it. So, and when our instructions here too is the filters in there, and that's basically catch any bad stuff coming back into it, and then any of the dirty gas or dirty air coming in. And one thing we found with that is, in some cases, that the filters do restrict the flow a little bit. So in some cases, we wouldn't recommend you running them. So another thing that's real important is to keep the tubing lines as close to the valve as possible. Because you get air moving in and out of this every time it makes a pass through that. So you've got to fill this fast and also drain it fast. So if you have leakage going on in here, the solenoid here has an orifice in it, and in some cases they leak more than the orifice can vent off. So we run into problems with the valves not syncing right. So, and another valve from Cooper. You got a little weep hole right here that will bleed off the air from the back side of that. But in some cases, air just pours out of that because the valve itself is so wore out that it doesn't operate properly. So again, real important. You got to make sure these valves are in very good condition to make the system work. This is on a Worthington, another type valve where they have and I have another picture. They have a brass bushing in here, and then they pump 250 pounds of air into here, and then it can leak by there. And they do, in some cases, they have a weep hole in here, but sometimes it's not very large. So you get leakage by here, and it gets on the backside of the piston, and then it makes a cycle time of that valve. So it ends up screwing up trying to get the engine started. So we had a customer that actually installed some sealing rings. They had a machine here and put some sealing rings on here to try to eliminate some of that leakage going by. This is the port I was telling you about where the air leaks out of. And I've been on some of the engines where the air just roars out of there. I mean, it's got 250 pounds on it, and it just comes out there where if you had tried to put your finger on it, it would actually, it's amazing how much they leak. So this is one of the fixes they tried, and it seemed to have worked somewhat. So. Another picture of how we got them solenoid set up. Again, like I said earlier, we really recommend keeping that tubing as short as possible because this thing is cycling back and forth. It's charging this cylinder area, piston area here, and then it's got to bleed it all back out again through this orifice and then do it again every revolution to keep the cylinders firing on it, or keep the cylinders rolling on it. So. Now, this is something that we've been experimenting with X-Line, and I think it's almost become a standard now. It helps eliminate the problem with these leaky valves there somewhat, and X-Line has had extremely good luck with it. And what the difference is on this one compared to a normal solenoid valve is the orifices on this are a lot larger, so it will take up a lot more leakage from these old valves. And it seems to be working very well. I mean, they've been around in the field for a long, long time. If you recognize them, you normally would have seen them on a pocket loader on a compressor side, where it would load or unload a pocket. So they're very durable. They seem to last a long time, and they've been really a good improvement with the SaveAir system. Where the point where some of these engines that we can only get like 30 or 40 pound or a RPM on them are running between 80 and 100 now because of just by adding this valve on it. So I think it's a really nice upgrade if you are having problems with the system and you don't know where to go. We've been having good luck with that. So this is one setup on the engine there. So the Clarks. We're going to talk a little bit about that. It's sort of a cool system we have because we pretty much replace everything on the Clark. We add its own valve in it, and we, even though it has a camshaft underneath these green boxes here that opens and closes a valve, that all that mechanical stuff that wears out and it has a lot of maintenance in it. We sort of eliminate all that, and then we add our own hose and our own valve here, solenoid valve here, and then we've got a big, I think it's 1.5 inches possibly, or 1.25 inch valve here that we supply air up to the heads on it with. So this is another Clark here with a little shorter system on it. Now, if you notice here, we had a check valve here too, and we recommend running that to protect the hoses and the valve, because the hoses and valves are designed of a 250-pound working pressure, and if the mechanical check in the cylinder head fails and you get combustion pressure in here, you could overpressure the hose or the valve. So we recommend that you add the check valve, but one thing we have found out here recently is by adding this extra weight up here, and I'm not sure it would bother this design any because it's a fairly short hose, but in this case here, with all this extra line up here, adds a lot of stress to this part of the valve. And we've had, because these valves are pretty old, and we've had some customers where it actually has cracked the valve, not the inline check valve, but the one that goes in the head. It was actually broke the valve they blame it on the extra weight. So one thing we are recommending with this, and we've added it to our literature, is to add a thermocouple in here for safety purposes. So if this valve starts to leak and gets hot, we can get the engine shut down before this system here sees combustion pressure. So very important that you look in, if you're going to do a Clark, to look into that. If you don't want to run the check valve, is to put some type of heat sensing detector in it, whether it's a melt out or a thermocouple or something to protect that, to protect the hose and the valve, for safety backup on it. So. And this is the hose that we recommend here, that we sell. And if you notice, right in here, there's a little coupler in there that where you can add a melt out or you can add a thermocouple in there. So the hose comes that way, so it doesn't need to be added or nothing. You just got to add some type of shutdown device where it will protect that part of the system. So. And this is what they do on that for the Clarks. For the mechanical valves in there, you can see where they've got a hacksaw here, and they actually cut the top of the valve stem off and just drop the valve back inside the inside the box there. And now the cam can't get to it anymore where it can open and close it. It just sits there in the bottom on it. So, and that's the way they do how to shut the air off on a Clark. So they have in some cases put like a steel plate in there also, but this is pretty much what everybody is doing. So again, to set a system up, you're going to know the firing order so you can program the box correctly. So you want to find either a nameplate or something in the book or one of the customers that know how the engine's set up, so you can program the box, the module, to know, so it knows where to inject the air into. So. We've been through a lot of this already as far as this air pressure sensing and the pressure transducers, as far as turning the system on and off. And it knows, since it when we get a program, it knows where to inject the air at. So there's no reason, it doesn't have to be rolled overing like that. It knows all that already. So. And then it also can maintain a set RPM where it varies very little for startup and purging of the engine. So, and then again, like I said earlier, it can also has a output that can turn the ignition on after the engine has a good purge on it before it to eliminate the backfire issues. So. Now this is what we talked about earlier. So this was on a GM. It was a 6-cylinder, and this curve's been around for a while, but you can see the amount of air it used up on the top one here on this engine number 8, where when we open up the valve, and this is a mechanical side here, their OEM system, and it starts pushing air in there, and then as the engine's rolling over, you can see it continues to just burn up large, massive amount of air that's not necessary. But in mechanical system, there's no way to control that. So, and after the SaveAir was installed, you get a little bit of bump here at the beginning to get the engine rolling because we've got the valves maxed out as far as duration on them. And then after we got the engine rolling, we were able to cut back the duration on when we were injecting air in down to a minimum, still maintain the same speed, but only give it a little bit of air to keep the engine rolling over. Similar to like when you were a kid and you got your bicycle tire and the bicycle's upside down and you hit it with a garden hose. You need a little bit of water pressure to get it going, but you just need a little bit of water to keep it going. And that's basically how the system is designed to work with. So you'd be surprised if you play around with the program a little bit, how little amount of air it takes to keep that engine rolling at a good RPM. So this is what the terminal program is going to look like. It's very easy to set up. I mean, if you got to know where the top dead center is on your cylinders, that goes in here. This is, of course, a 10-cylinder engine. And then this up here, this is the where we're going to start injecting air at. And this is 5 degrees after top dead center. So it would be this point right in here at the beginning of this area here. And then we're going to inject it at the beginning at 100 degrees duration. So in this case, since we're going 5 after, it's going to go 105 degrees after. So this amount of time is injecting air into the system. And then we're going to do that until the engine gets up to 20 RPM, and then we're going to back it off to about 90 degrees. So in this case, it would be about 95 in here, what would shut off. And as the engine reaches 30 RPM, we've kicked it back down to 80. And then when it gets up to around 75 RPM, we've kicked it back down to 50. So we've basically cut the air in half on it that we're injecting in. We started out here, but then we'd be in just this little area right in here is where we're going to be injecting air in it to maintain that speed on the engine. So as you can see, the amount of air that's being wasted here, we don't need that now after the engine gets cranked up and running on it. So, and again, that's pretty much how you program it. I mean, in some cases, we've had customers actually put a negative number in here after they get the engine rolling. So they're actually, in some cases, injecting air maybe 5 degrees before top dead center, and then cutting it off real early afterwards, just to fill up that void on top of the piston. And it also has what we call a rock and roll system on it. It's used very, very little, but the thing has the and it's just the way you program it. Where if you get an engine that has a dead spot on it, we can program this thing so it senses that and it actually pushes the engine backwards a little ways, where it gets into the next cylinder, so it has a full stroke on it. So that, again, that's another way to help with that dead spot on it. But again, it's only been used a handful of times, and even to program it, you got to sit back and remember how that's done. But it does work. So. This is a case where you can see this is where our, if it was a mechanical engine, you see our red arrow here. Now this is the first cylinder it's going to start injecting air at. As you can see this big area here, there is no place to inject air at. So in this case here, the engine will not crank because it's just got done crank, or if it was here on the number 1 cylinder, it just got done. So this part of the part has shut off. And there's nothing to jump in here. Well, if it was a mechanical system, there's nothing you could do but actually bar the engine over a little bit until you got the cylinder number 2, and then it could start injecting air again. And then this one here would pick it up, number 3, and then so on to get the engine rolling. So and this happens a lot, with a mechanical system. So the neat thing about the SaveAir is, again, I pointed it out here. Now you've got 5 spots in here that if this engine happened to stop in that area, you couldn't roll it over because you'd have to physically bar the engine over. And this is actually an OEM system on it that only inject air for 95 degrees. So this is something that doesn't happen once in a while. This actually was built this way from the factory with this mechanical drive. So one of the cool things about the SaveAir, if you know when the exhaust port opens up or if the exhaust valve opens up, you can set up your SaveAir. Let's just say that the exhaust valve opens at, say, 130 degrees. Well, now you can set this up so it will inject air up to 125 degrees, and then it kicks into the second cylinder. So now in this case, if the engine stopped right in here, number 2 would open up, and then we could start rolling the engine again. So we've eliminated all these dead spots in here. Again, you need to know either when the exhaust ports opens up or when the exhaust valve opens up, because you only got a certain period of time there that you can actually push air into the cylinder where it's not leaking out of a valve someplace. So that's one important thing to know. If you're either an engine analyzer guy or you have that kind of data, they can tell you when that valve is going to open up. So, and that's how we set these up. Then then after the engine starts rolling, then we'll take this thing and maybe back it off to I don't know, maybe 50 or 60 degrees, and only use this section here to keep the engine at a certain speed. So, okay, that's all I got, guys. So if you have any questions, feel free to ask them, and this will be the time to do that.
Mike, right. Questions for Mr. Porter? Questions for Mike? You know all experts, Mike. Well done.
Well, if anybody out there, if you are setting one up and need any help, feel free to give me a call, and we'll set up a time and give you a hand doing that. So.